Okay, question 2. Classic, isn't it? Classic. We've seen these time and time again. Your polynomial skill solving equations where you've got a factor bigger than 2. So quadratics is your factor of 2. Now we've got a factor of 3. And to do that, we're going to use our synthetic division. So just going to write out my coefficients for my different terms. The way they might make this tricky is to miss out some terms. So for example, if there was no x in 2, I would have to have a 0 and a 0 here. If there was no x squared term, I would have 2, 0, 1, 2. So just watch out for that. Sorry. I still got this all code. The other thing to note is that the number I put in here is the root of the equation. Okay, so we should know that a standard parabola will have the form x take away a, x take away something like that. Okay, and if that was my root, so say this was that'll be a negative a, and that'll be a plus b. That means that in here the signs change. So actually that would be a plus a, and that'd be negative b. We change the signs in the brackets. So that's our solutions. That's the roots of the equation, and the brackets have the opposite sign. So it's the same for our polynomials. If I've got a power of 3, I should have 3 roots. X take away a, x take away b, x take away c. Yeah, you can imagine. I'll just move over. There we go. Look at that. So you get 3 roots now, and again it's the same. This is a. This will be negative a, positive b, negative b, positive c, negative. You change the roots. So that's the number that goes in here. It's the actual root of your function. Okay, I'm actually going to just try and draw that slightly nicer because it is quite it's quite shocking. There you go. And the other thing I'll note while I'm on this is if you have a root which is on the axis. So if I drew something, I'll say for this one, say that was just negative a, and that's positive b and positive c. I'll just write that up there as positive a and negative b, negative c. True. But if I had another one, if I had something like this, where I went through, see, I went through like this. I won't do that. I went through like this, and then down. So see this root here, this is my repeated root. So that would then show up as a squared term. Okay, so that'd be x plus a squared, x plus b. So just, sorry, x take away b. So just remember that if you have a repeated root in there. So look, nothing to do with the question. I just feel that this will say negative a. I just feel this is quite a straightforward question, but to give a wee bit more depth around what's going on is worthwhile. Okay, so remember this when you're thinking of your solving polynomials. So first thing we do is we bring the 2 down. That's how we start. So we've got our coefficients. We start with the 2 here, and we put in the opposite sign from this because we put in the roots. And then it's just multiply and add. Okay, so 2 times 1 is 2. Add them together, then multiply, add them together and multiply, and yes, fantastic, my remainder is 0. So you want to finish off by saying the remainder is equal to 0, therefore x take away 1 is a factor, yeah, not a factor really. X plus 1 is a factor, but is a root, is a factor is a better way of saying it, sorry. Yeah, x plus 1 is the root, and that's the factor. So that's your first bit. Should be quite straightforward for that, and you'll get your 2 marks, but you would lose a mark if you didn't have your statement, so make sure you do that. And when it's asking you to solve it equals 0, it's really just saying we'll factorise it. So I know that I've got x take away 1, and now what I need to do is take this bit and factorise that further. Okay, so that bit in there becomes 2x squared, take away 3x, take away 2, and this is equal to 0. And you see there that that is just the same coefficients, but the power has now been reduced by 1. This was the cubic column, now it's the square. This was the square column, now it's the x. Okay, so that's right. And now we're going to factorise this, so I'm looking for a number that adds to negative 3 and multiplies to negative 4. So I'm thinking then, and I'm just going to go off to one side to do this, I'm thinking that's going to be, they stay the same, it'll be negative 4x plus x. That looks good to me. So then you break it in 2, take your common factor, x take away 2. Fantastic, and I have to put a little 1 in front to make that fly. So that's 2x plus 1 and x take away 2. This is the trickiest form of factorising. The basic trinomial where you've got a 1 in front of here is a bit easier. Don't forget you get difference of 2 squares as well. So that's that one factorised. So let's just put this all together. So x take away 1 stays where it is, and I can rewrite that as 2x plus 1 and x take away 2. And notice that the question says, it doesn't say factorise fully, it says solve. So this is the factorise fully line, and you wouldn't have to go any further if that was the question, but it does say solve. And by solve, it means what are your roots? So x is going to be 1, x is going to be 2, and this is saying 2x plus 1 equals 0. So you're rearranging to make x a subject, so it's negative a half. Okay, so each time you're doing that, you're making this equal to 0, but really you just change the sign. But just in case you see these and they're a bit trickier, this is equal to 0, rearrange to make x a subject. So take away 1 and divide by 2. And let's just check to see our marks for that, so plenty of time. So you're getting a mark for stating your new function here, and then you're getting a mark for the remainder. Absolutely, yep. So a mark for actually factorizing, and then for writing down all your x values. Quite straightforward, really. So nice question, that one. Really nice. They can't dress it up in too many different ways. You see this almost exact same question coming up over and over again. So get good at your synthetic division. Don't forget your statement, and just think what you're doing each time. Okay, you are finding the roots of your equation. This is your factorized form, fully factorized. This is it solved. So the equal to 0 simply means when y is 0. So there's your y line. So when is y 0? Well, 0 when the equation goes through the x-axis. Okay, and then I'll give you a little bit of chat about how to visualize them as well. Don't forget a turning point on this axis, and you'll have a square term in there. That comes up quite a bit when you're interpreting graphs and things. Okay, so yep, hope that's helpful.